We should start with the first experiment. So look at the aim of an experiment: to simplify a given 4-variable logic expression using an entered variable map, and to realize the simplified logic expression using 8:1 multiplexer. This is the first experiment in your lab. Okay. As I already told how to write the record, let me go with the experiment directly. So basically, to perform this experiment, you are supposed to make use of an IC. The IC number is 74151. Okay. So look at this IC configuration. This is D3, D2, D1, D0. This IC has been configured like this. So you can ask me a question like why the pin number 1 is D3, why the pin number 2 is D2. We don't have the answer. Okay. The manufacturer have been designed the IC like this. So you should remember the pin configuration of 74151. Okay. 1 is D3, 2 is D2, 3 is D1, and 4 is D0, 5 is Q. Q refers to output, and 6 refers to Q bar, and 7 is enable, 8 is ground, and 9 is A, B, C. Hope you remember the multiplexer experiment, multiplexer problems, where you find out the control input. Based on the control input, it is going to decide which input has to be passed on to the output, right? So that is how the multiplexer is going to work. Similarly, A, B, C are the control inputs. A is the most significant bit and C is the least significant bit. So 8:1 multiplexer means obviously we will be having 8 data inputs and 1 output, right? So if we have 8 data inputs, how many control inputs? 3 control inputs. 2 to the power of 3 is 8. 3 refers to control inputs and 8 refers to data inputs on 1 output. Okay. So we have 8 data inputs. That is what D3, this is on D7, D6, D5, D4, D0 to D7. 8 data inputs, 3 control inputs. This is a 16 pin IC. 16 is VCC and 8 is ground. Okay, you need to learn this IC configuration. If you get this experiment, you need to write this IC pin configuration. Then you need to start with an expression. So again, you need NOT gate also to construct this experiment. It all depends upon the expression. So for example, if the expression is like this, okay, for this expressions, you might get like D bar, D. I hope you know how to write this table, okay. I have made you people to solve this problem in the theoretical classes. The same way you need to write. At last you will get D bar, D. If you get a D bar, then you are supposed to make use of a NOT gate. If there is no bar in the expression, then then there is no point in using a NOT gate, okay. Your examiner might ask you people to make D as map entered variable, or A as map entered variable, or B or C. It all depends upon the examiner. Okay. This is how the design. Starting with 0, 0, 0, 0, 0, 0, 1, 0 to 15 they have written. This is A, B, C, D. D as map entered variable. So we have only 3 inputs like A, B, C. Okay, we don't have D. So D is like we have 8 data inputs. So altogether we are choosing one D here. So we have made D as map entered variable. Okay. So 0 to 16, 15 they are written. So this is 0, 1, 0, 1, 0, 1, 0, 1. This output Q is written based on the min terms 0, 2, 3, 4, 5, 8, 9. Which are the min terms they are given. Just fill the respective positions with ones. Okay. So after this you need to compare this D column with a Q column. If it is 0, 1, 1, 0, you need to write D bar. 0, 1, 0 is 1 and 1 is 1. Both are 1 and 1, write it 1. 1 and 1, 1, 0, 0, 0, 1 and 1, 0. Like 0, 0, 1, 1 means D. If we have 0, then it is 0 means D. Same. 0 means 0, 1 means 1 means you are supposed to write D. If it is reverse, okay, then you are supposed to write D bar. If it is 1 and 1, 1, 0 and 0, 0. This I explained already in the previous theoretical classes, okay. So based on this, you need to write this 8:1 multiplexer. So you are supposed to make use. Okay, look at this. This is 74151. Okay, 1, 2, 3, 4, 5, 6, 7, 8, and 9 to 16 they are written. So you know the pin number 1 is D3, pin number 2 is D2, pin number 3 is D1, pin number 4 is D0. You can look at here. What is D0? What is D0 here? D0 is D bar. So you are supposed to take a wire from D and connect to the 2. Why 2? Because this is a NOT gate. 1 acts as input, 2 acts as output. If you pass D at 1, 2 will be D bar, right? So D0 is D bar, So you're supposed to connect this D0 wire from D0 to the output of NOT gate. So similarly D4 is D. So look at here, where is D4? Here it is. 15. Take a wire from D7. It's D7. D7 is D. Take a wire from D7. Connect to the input of NOT gate. Why it is input of NOT gate? Because this is D. Should be connected to input of NOT gate, and D bar should be connected to the output of NOT gate. When you get D bar, something like that, you are supposed to use NOT gates. If there is no bar in the table, then you are not supposed to use any NOT gates here. So then look at this. D1 is 1, D2 is 1, D4 is 1, D5 is 1, D6 is 1. So connect D1, D2, D4, D5 and D6 to VCC. Look at here. D1 is connected to VCC, D2 is connected to VCC, similarly D6, D5, D4 all are connected to VCC, and 16 as usual connected to VCC. So look at this. D3 is 0. D3 is 0 means where is D3? D3 is here, connected to ground. Okay. So this is how you're supposed to make a design. So after making a design, you're supposed to make the connection based on this circuit diagram. So I have already made the circuit connection here. So this is how the circuit connection looks like. So I will just go with the output. I will just show the output, how the output appears. These are the inputs, right? These are the outputs. So this is Q. So as I just told, Q is the output. A, B, C are the control inputs. So this is A, this is B, this is C. Okay. So look at here. This is A, this is B, this is C. These are the control inputs, and this is D. I have taken a wire from D. I will tell you how the D connection has been taken later. So these are the control inputs A, B, C, D. If you make a changes, the output will appear here. Okay. So look at this table. These are the inputs A, B, C, D, and this is the output. You need to give the input 0, 0, 0, 0. The output should be like this. So right now all are 0, 0, 0 means low. The output is 1. Look at here. Here it is 1. Next 0, 0, 0, 1. So I will 0, 0, 0. I will make it as 1. Look at here 0. Look at here. It is 0. So let me go with 0, 1, 0, 1. The output should be high. I will go with 0, 1, 0, 1. The output is high. Similarly, I will go with all high. If I give 1, 1, 1, 1, the output is high. See, all are high. The output is high. If you want to go with low, means 0, 1, 1, 1, 0, 1, 1 is low. See, 0, 1, 1 is 0. So there is one more here. 0, 1, 1, 0. 0, 1, 1, 0. Again low. So you need to check for all the possible conditions. The output should appear like this. Output, if all the inputs, the output satisfies, then your experiment is right. So look at this. This is the 74151 and this is 7404. This is how the experiment looks after making connections. It will be very difficult for you people. If something goes wrong, there will be more number of wires will be here. So you will be under a confusion which wire connected wrong, something like that. Okay. So before making connection, you need to be thorough with where you are inserting the wires. Okay, I will show how to make the connection now.